Another question that was asked from Larson, section 3.4, was number 39, which says f of x is cosine x minus x, and we're looking to find all relative extrema and use the second derivative test where applicable, and that's on the closed interval from 0 to 4 pi. We'll write a short note here. What is the second derivative test? Well, it says that if f prime of x is 0 and the second derivative is negative, then f of x has a relative maximum. In picture, that means that at the peak of that curve there, the first derivative is 0, and since the function is concave down at that point, we can see clearly that there is a relative maximum there. Secondly, if the first derivative is 0 and the second derivative is positive, then f of x has a relative minimum. So in this graph, we see that we have a 0 derivative at the bottom, and since the function is concave up at that point, we can see that there has to be a relative minimum. Alright, back to the problem. But before that, let me give one more addition to that note. The second derivative test also states that in the event the first derivative is 0 and the second derivative is 0, then the second derivative test is inconclusive. And you have to use the first derivative test, which means you have to do the sign charts and go about it that way. Alright, so let's now get back to the function. If the function is cosine x minus x, then the first derivative is going to be negative sine x minus 1. And that will equal 0 when negative sine x is equal to 1, or sine x is equal to negative 1. Now sine x is equal to negative 1 at 3 pi over 2 and at 7 pi over 2. So to do the second derivative test, what we would need to do, now the second derivative test, the second derivative is just going to be negative cosine of x, which will be 0 whenever cosine of x is 0. But actually, we don't need to go that far. All we want to do is plug in the points 3 pi over 2 and 7 pi over 2 into negative cosine of x and see whether we get a positive or a negative value there. So cosine of 3 pi over 2 is 0. So negative cosine 3 pi over 2 is also 0. So the second derivative test is inconclusive there. Let's do 7 pi over 2. 7 pi over 2, we're going to have the same exact problem. So in both cases, the second derivative test is inconclusive, and what we'll have to do is go back to the first derivative test. Alright, so I'm going to then get rid of that whole section because the second derivative test was of no use to us there, and we'll have to go back and make a sign chart. Okay, so that part is the second derivative was not helpful. And what we'll need to do is to make a sign chart where we want to test the values of f prime of x somewhere below 3 pi over 2, between 3 pi over 2 and 7 pi over 2, and above 7 pi over 2. Now recall that the first derivative is negative sine x minus 1. So the test values that we want here are, we're looking for values that are good values to test sine at. And we could find values where sine is equal to 0, and that would be at pi, at 0, at 2 pi. And since we're working on a closed interval, we can use the value 4 pi also. Alright, so plugging pi into sine of pi is 0, negative 0, minus 1 gives us a negative. Plugging in 2 pi, we also get sine of 2 pi is 0, negative 0 minus 1 is negative again. And at 4 pi, sine of 4 pi is 0, negative 0 minus 1 is still negative. Now that might be disconcerting because it says negative, 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 and it never changes sign, which might indicate that we have a graph that looks something like the purple line I drew on the right there. And without a calculator, that's really the best that you could do, is assume that that's happening. And just briefly, I bring up a graph of that function and see that that is exactly what's happening. So there are no relative min or max.